There are moments in conceptual mobility design when a vehicle stops behaving like transportation and begins behaving like infrastructure. This is one of those moments. What stands before us is not merely a recreational platform, but an architectural object on wheels, a speculative study in extreme terrain luxury habitation that borrows equally from armored expedition vehicles, aerospace surface modeling, and high-end maritime design. Before we go further, it is important to clarify something with composure and transparency. This motorhome is an AI-generated fictional concept created for imaginative exploration and design discussion. It does not exist in physical production, nor is it tied to any manufacturer. What we are evaluating here is a speculative engineering and design exercise, a thought experiment in future-forward mobility architecture, and it deserves to be analyzed with the seriousness of a Geneva-level concept unveiling. Based on proportion scaling relative to the wheel diameter and cabin height, this vehicle appears to measure approximately 13 to 14 meters in length, with a width likely exceeding 2.6 meters and a roof height approaching 3.8 meters, excluding the upper deck platform. The stance is deliberately assertive. We are observing a 6-axle configuration, 3 driven axles at the rear, and a dual-steer front configuration, suggesting an 8x8 drivetrain logic optimized for load distribution and extreme off-road articulation. From a structural engineering standpoint, the chassis segmentation is particularly interesting. Rather than a single extended mid-body span, the chassis appears modularized, distributing mass evenly across the axles to prevent torsional overload in uneven terrain. This implies a ladder frame or reinforced space frame architecture capable of handling significant torsional stress without compromising interior structural integrity. The ground clearance is substantial, likely exceeding 400 millimeters, indicating long travel suspension geometry. Given the mass this structure would carry, a hydropneumatic adaptive suspension system would be a logical solution, allowing dynamic ride height modulation and self-leveling capabilities for stationary habitation. This is not designed for paved campgrounds. This is engineered, conceptually, for geological instability. At first glance, one might assume aerodynamics were secondary to intimidation. However, the surfacing tells a more disciplined story. The front fascia features sharply chamfered planes, angular transitions, and tightly controlled crease lines that guide airflow around the cabin perimeter rather than allowing blunt force stagnation. The windshield rake is surprisingly aggressive for a vehicle of this height, reducing frontal drag coefficient compared to traditional vertical RV glass panels. The roofline tapers slightly toward the rear, a subtle but meaningful gesture in drag reduction. This suggests the design team, hypothetically, understood that even high-mass vehicles benefit from pressure management at highway speeds. The panel transitions are complex, yet coherent. Notice how the red and graphite black surfaces interlock through layered geometric segmentation. This creates visual tension while simultaneously implying reinforced armor plating, an aesthetic borrowed from aerospace fuselage segmentation. Surface tension modeling is tight. There are no bloated curves. Every edge appears intentional, almost tactical. The exterior finish combines matte graphite composite panels with deep metallic red inserts. The reflective quality suggests a ceramic-infused coating capable of high UV resistance and thermal dispersion. In real-world application, such a coating would serve two primary purposes: minimizing heat absorption during extended desert exposure and resisting microabrasion from sand or particulate impact. The black sections likely imply carbon-reinforced polymer cladding, not necessarily for weight savings alone, but for impact resistance and corrosion immunity. From a thermal standpoint, the dark upper surfaces would require integrated insulation layers beneath, possibly aerogel-based composites, to prevent radiant heat transfer into the living quarters. Diffusion across the angular contours produces dramatic contrast, but beyond aesthetics, the sharp breakpoints reduce surface flare and wind-induced vibration at speed. This is theatrical, yes, but it is also mechanically intentional. The lighting strategy is perhaps the most assertive design signature here. The front fascia integrates a multi-tier LED hierarchy, a continuous upper daytime running light strip, secondary accent clusters embedded within angular housings, and lower bumper-mounted auxiliary arrays for terrain illumination. The blue illumination elements are conceptually interesting. In a real-world scenario, blue lighting would typically be restricted due to regulatory limitations, but as a conceptual identity statement, it communicates technological dominance and electric-era futurism. The wheel hubs themselves feature illuminated ring elements. From an engineering perspective, this would require sealed rotational LED modules powered through inductive systems or slip ring assemblies. While complex, such technology exists in limited applications and could theoretically scale with durability enhancements. The night presence of this vehicle would be architectural rather than automotive. It would read as a moving installation, a luminous structure traversing terrain. Glass architecture and structural implications. The side glazing is generous but controlled. Unlike traditional RVs that rely on expansive, uninterrupted glass panels, this design integrates segmented windows within reinforced structural frames. This indicates an understanding of shear rigidity requirements in off-road applications. Large, uninterrupted glass would compromise torsional stiffness. Here, the window geometry supports load-bearing framing between apertures. The tint density appears moderate to high, likely triple laminated acoustic glass with electrochromic modulation capabilities in a future-ready scenario. Electrochromic glass would allow adaptive opacity control, balancing privacy with panoramic openness. Given the vertical height of the cabin, insulation would need to address both thermal bridging and acoustic dampening, particularly in high-wind, desert, or alpine conditions. Wheels, tires, and chassis philosophy. The tire profile is aggressive, deep-lug all-terrain, likely 40 inches or greater in diameter. The sidewall depth suggests reinforced beadlock compatibility for low-pressure crawling conditions. From a load compensation point, 6 axles distribute weight to prevent ground pressure overload, crucial when traversing sand or mud. The rims themselves are aero-disc styled but reinforced for torque stress. If this concept were real, each axle would require independent differential locking systems to maintain traction across irregular terrain. Suspension travel appears substantial. Wheel well clearance indicates at least 250 millimeters of vertical articulation. For a vehicle of this mass, active damping with predictive terrain scanning would be a logical evolution. Roof systems and upper deck integration. Perhaps the most provocative architectural feature is the upper circular deck structure. It resembles a marine observation lounge integrated atop a terrestrial vehicle platform. Structurally, this presents enormous challenges. Raising mass upward increases center of gravity and rollover risk. To counteract this, battery packs or heavy drivetrain components would need to be mounted extremely low within the chassis rails. The roof also appears to house auxiliary lighting arrays and possibly sensor modules. For a future long-range mobility platform, one could imagine LiDAR and satellite communication dishes integrated seamlessly into this upper deck perimeter. Solar integration is plausible across the roof plane. However, given surface segmentation, efficiency would depend on flexible photovoltaic layering rather than rigid panels. Front and rear identity. The front grille is largely sealed, suggesting electrified propulsion logic. Cooling requirements would therefore focus on battery thermal management and motor inverters rather than combustion airflow. Air intake channels are subtle and angular, likely guiding airflow toward hidden cooling ducts beneath the body. At the rear, the lighting symmetry appears horizontal and disciplined. There is no exposed exhaust architecture, reinforcing the electrified assumption. A rear diffuser-like lower geometry implies airflow exit management, reducing underbody turbulence. This concept redefines the luxury expedition segment by rejecting the soft-edged motor coach template. It leans heavily into aerospace and tactical industrial aesthetics. There is minimal reference to traditional RV softness or leisure nostalgia. The intended user archetype is clear, not a casual weekend traveler, but a technologically affluent explorer who values autonomy, resilience, and architectural presence. From a maturity standpoint, the exterior surfacing is highly resolved. The proportions feel deliberate, not exaggerated. While dramatic, the geometry remains structurally plausible within advanced material engineering contexts. My first professional impression is this: it behaves less like a motorhome and more like a mobile command habitat. It is a study of Even though the interior is not visible, the exterior engineering allows us to logically infer its structural organization. Given the length and height, this platform likely employs a dual-deck configuration. The lower deck would house mechanical systems, battery arrays, water tanks, and possibly a garage or utility bay. The upper deck, including the circular observation platform, would serve as the primary living and social zone. Load paths would need to channel vertically through reinforced bulkheads aligned with axle mounting points. This ensures that habitation weight does not create mid-span sag over time. Ceiling height internally could realistically approach 2.2 meters in the main salon area, provided structural beams are integrated within wall thickness rather than overhead. Sleeping quarters would logically be positioned mid-ship for optimal weight balance. Placing heavy cabinetry too far rearward would compromise handling stability. Acoustic insulation would be critical. Triple-layer composite wall construction with vibration-dampening membranes would isolate sleeping areas from drivetrain resonance. Glass-to-privacy balance would be managed via electrochromic dimming combined with retractable insulated panels. In real-world use, such a cabin would feel acoustically insulated, almost studio-like, despite exterior ruggedness. A vehicle of this scale would likely feature induction-based cooking systems powered by high-density solid-state battery arrays. Water storage would need to exceed 600 liters for extended off-grid autonomy. Gray water recycling systems with filtration membranes could extend usability by up to 40%. Appliance integration would favor flush-mounted composite surfaces to reduce rattling and vibration. Energy consumption logic would prioritize load balancing algorithms, preventing peak draw overload during simultaneous cooking and climate operation. Given spatial allowance, a modular separation between wet bath and dry vanity area is plausible. Ventilation would rely on roof-integrated extraction systems with heat recovery exchangers to maintain climate efficiency. Water recycling, while complex, would be essential for expedition endurance. Driver visibility from the elevated cabin would be commanding. Given the width, side camera arrays would likely replace traditional mirrors. An augmented reality heads-up display could project terrain gradients and axle articulation data in real time. Semi-autonomous highway cruising is plausible in a future mobility scenario, though off-road autonomy remains technologically challenging due to unpredictable terrain variables. Control hierarchy would need to remain tactile despite digital dominance. In expedition conditions, physical redundancy is essential. From an engineering standpoint, a hydrogen-electric hybrid system would best align with this concept. Hydrogen fuel cells could provide extended range, while battery packs manage torque-intensive crawling. Regenerative braking across 6 axles would dramatically improve energy recapture efficiency. Solar contribution from roof surfaces might realistically provide 10 to 15% of auxiliary load, not primary propulsion. True off-grid autonomy could reach 7 to 10 days with intelligent load management. Climate zoning would be essential due to cabin volume. AI-driven environmental adaptation could regulate humidity, temperature gradients, and air purity based on occupancy patterns. Satellite connectivity integrated into the upper deck would ensure communication even in remote regions. Structural health monitoring sensors embedded in the chassis could detect stress fractures or suspension fatigue in real time. For long-distance touring, this platform would excel in durability but require advanced driver training due to size. Seasonal adaptation would be strong, provided insulation materials meet aerospace-level standards. Remote work practicality would be exceptional given the upper deck's panoramic potential. Terrain limitations would center on bridge weight restrictions and extreme incline thresholds due to mass. To transition from speculative concept to feasible prototype, advancements would be required in lightweight structural composites, high-density solid-state batteries, and hydrogen storage safety. Current limitations include charging infrastructure, hydrogen distribution, and cost of reinforced multi-axle drivetrains. Is this evolutionary or revolutionary? Architecturally, it is revolutionary. Mechanically, it is an ambitious extrapolation of existing heavy-duty expedition engineering. What fascinates me most is not its scale, it is its confidence. This concept challenges the idea that mobility must shrink to become efficient. Instead, it proposes that autonomy, resilience, and architectural presence can coexist in a single engineered habitat. As a speculative study, it invites us to ask a larger question. Not how big a motorhome can be, but how intelligently integrated a mobile environment can become.